Well, hello everyone, and thank you for attending my talk. I am Nicolas Kourtellis, and I am a research scientist at Telefonica Research in Barcelona, Spain. Today, I will present to you our position paper that outlines the current needs in the ecosystem of data stream mining and our proposed system to address these challenges. We call this Stream to Cloud and Edge, or S2CE for short. This is a hybrid cloud and edge orchestrator for mining exascale distributed streams. This is a joint work with my colleagues Herodotos from Cyprus University of Technology, Maciej from Warsaw University of Technology, Piotr from Lodz University of Technology, and Albert from University of Waikato and Telecom Paris. The current landscape we have at hand is the following. We already have tens of billions of devices which are expected to grow by 2 to 3 times in the next decade. Collectively, they produce big data characterized by the typical 4 V's: large volume, velocity, variety, and veracity. At the same time, there is a constant need for data modeling via machine learning and deep learning to extract values from this data, which is the 5th V in the big data. However, the typical infrastructures used for such data aggregation and machine learning analysis are very heterogeneous and cannot be easily integrated with each other. They also have significant overhead to manage them. Also, users experience vendor lock-in when they choose to work with a certain infrastructure, even though recent changes from top cloud providers may have started alleviating this problem. Finally, the current model of data collection and processing is not sustainable. Infrastructures are already stressed and would not be able to scale to produce in real time the big data streams to be produced by the expected billions of devices of the future. To solve all these challenges, we propose S2CE to utilize current technological developments such as hybrid edge and cloud infrastructures with streaming AI technologies. A motivational scenario could be a telco infrastructure, which needs to process data originating from its users and edge devices. In this scenario, S2CE would need to consume big data from different sources destined for different types of analysis. This input data can range from data in motion, such as events produced from mobile or IoT edge devices, or up to fully processed data at rest or in motion that are stored from other complete cloud platforms inside the telco infrastructure. The processing may require different types of systems and machine learning to be applied before analytics can be computed and visualized at the end. Another example is a bus company that may want to collect data to optimize bus routes and perform data-driven business decisions, but can also sell such data to a city council that has its own cloud infrastructure to bootstrap their effort to optimize traffic and reduce congestion and pollution in the city. This crucial property can drive high business innovation in the data sharing markets as required and expected by the emerging world data economy. Regarding what is the current state of the art, we analyzed various platforms and systems available nowadays. We performed this analysis by studying them if they are designed for big data streaming processing, cloud resource management and tuning, stream processing at the edge, machine learning on data streams, or data transformation. A summary of this analysis showed that none of the existing systems and libraries can provide the necessary functionalities to overcome expected challenges of the future. This is especially true when it comes to combining cloud and edge orchestration, as well as having capabilities to perform AI on data streams. Looking at the problem from a different perspective, according to the Big Data Value Association, there are various industrial challenges expected in this space of big data processing in the future. If we were to group them, we find that some of them reflect challenges related to scalable and heterogeneous data processing, edge and cloud infrastructure, analytics based on machine and deep learning, as well as fusion and transformation of data inputted into the system, as well as outputted from the system. We merged the 4 design objectives of S2CE with these expected industrial challenges. Objective 1 is that we want a data processing platform capable of scaling in a distributed fashion on cloud resources to ingest exascale streams and utilize smart cloud resource management and self-tuning for reduced energy consumption, increased efficiency, easy configuration, and maintenance. The second objective is that we want a hybrid cloud edge architecture capable of scaling in a decentralized fashion to pre-process big data streams on the edge nodes by utilizing smart edge resource management for workload migration from the cloud to the edge nodes for energy efficiency and reduced latency. The third objective is that we want to provide the next generation of advanced stream analytics with distributed machine and deep learning to support predictive and prescriptive analytics of both data at rest and data in motion in a unified manner that empower business intelligence in the new paradigm of data economy. Finally, the fourth objective is for the platform to be able to support with tools for input and output data transformation and synthetic data stream generation based on real-world statistic distributions for ensuring data quality, interoperability, and replicability while enabling the privacy-preserving and confidential sharing of data. This is the general architecture of the proposed stream-to-cloud and edge platform. Next, we will briefly cover each of these main components. First, we have the input interface, which allows for consuming data from different types of resources, including data at rest or in motion, as well as data that come in from other S2CE infrastructures or other computing infrastructures. Then data streams are fed into the transformations component, which will be able to perform data pre-processing and fusion, visual exploration and model explanation, detect changes in online models, and privacy-preserving stream generator. The machine learning component takes input data and performs various algorithms for fast learning. Such machine learning streaming algorithms need to be incremental, use a small amount of time and memory for processing, and adapt to the changes on the streams. They also need to be self-adaptive to the streamed data. The cloud management component manages cloud resources efficiently, starting from the basic mechanics needed for cloud resource provisioning to algorithmic monitoring and distributed task management, and finally to self-tuning streaming applications automatically. The edge management component manages edge resources efficiently by understanding what streaming computation can be offloaded from cloud to the edge resources, where, meaning to which edge nodes, when this offloading should be done or reversed, as well as how the offloading will be done. The output interface component implements standardized, secure interconnections to allow the algorithmic results from the machine learning module to be outputted for downstream streaming engines, other S2CE instantiations, and even end users to consume on their devices in a seamless, secure way through a pipeline. The output data streams should also be splittable to different formats and substreams, depending on the utility of the overall pipeline. Finally, the cloud edge computing infrastructure interface component allows S2CE to operate on top of several well-established distributed stream processing engines, or as we call them DSPEs, such as Apache Flink, Storm, and Spark Streaming, or new DSPs that are invented in the future. We also assume two types of APIs, the internal and external. The internal API is responsible for allowing the various modules of S2CE to interact and exchange raw data, tune parameters, models, etc. The external API is responsible for consuming data inputted into the S2CE platform from various upstream sources, for example, other S2CE platforms or end-user devices, or output the results to downstream platforms and devices for consumption, further analysis, visualization, and storage. The figure on the left shows the different interactions between internal S2CE modules and external computing infrastructures or other S2CE platforms. The figure on the right shows an example of how someone can chain different S2CE modules to build a stream data processing pipeline that first performs some data transformation and then applies machine learning modeling and offloads compute tasks from cloud to edge devices. If we were to try and visualize how various current machine learning libraries and systems provide support for big data stream processing versus the number of machine learning algorithms they have at hand, we could get something like this picture. For example, here we see MOA, which has one of the richest machine learning libraries on stream processing, but is not designed to provide support for big data stream processing. On the other hand, the good old Apache Storm has a very nice scaling property, but not much machine learning library support. We envision S2CE will provide a better solution for both of these important dimensions in the near future. To summarize, S2CE has great innovation potential. In fact, we anticipate that the successful development and deployment of S2CE instances around the world from different companies can optimize resource allocation, software deployment, and runtime tuning across different cloud providers in a vendor-agnostic way. It can also provide task placement mechanisms and algorithms across edge nodes, as well as offloading methods for tasks to be migrated to the cloud from edge seamlessly and without impacting performance or latency beyond agreed SLAs. Finally, it can support Exascale-based data-driven analytics. For all this to be feasible, S2CE must integrate organically with the Apache ecosystem projects as a next-generation big data solution and enable innovation exchange within existing and future industrial solutions. In fact, S2CE can unify efforts in the open source space to produce a comprehensive machine learning library for big data stream mining. And with that, I would like to thank you for your attention and take any questions.